Hey everyone, I'm Arnav. I lead our machine learning team at Predibase, where I focus on fine-tuning and inference advancements. And previously, I worked at Atlassian as a machine learning scientist, where I built a lot of large-scale recommendation systems that powered a lot of smart features in Atlassian products like Confluence and Trello. Today, I'll be talking about strategies for updating machine learning models in production using data collected from production to ensure that you can see continuous model quality improvements while also keeping your costs in check. For those who are familiar with deploying LLMs in production, especially if you are already doing this with fine-tuned models, I created this diagram that highlights the Gen AI fine-tuning lifecycle. It essentially showcases the iterative process of leveraging usage data to fine-tune and improve models continually. And typically, this starts with prompt engineering and serving a base model as step one, collecting production data from usage, right? Like it could be an open source model or a closed source model, but you collect that data, happens very often. Fine-tuning an open source LLM using this data, and then selecting the best fine-tuned model for deployment. Now, a lot of users actually stop once they have their models in production. However, this feels like a lost opportunity given that you have the ability to collect more and more usage data over time. So the question we should really ask ourselves is, how can we leverage this new production data to continuously improve our models? And at Predibase, we think that the best-in-class teams will retrain constantly as they collect data from production, starting with retraining maybe, let's say, every month, and then maybe moving to weekly or even daily, depending on how frequently they're able to collect a reasonable amount of data or how quickly they want to incorporate feedback. We've seen Predibase customers do this within the product to iteratively improve their models time and again. And for those of you who might be unfamiliar, retraining is useful for a variety of reasons. The main thing it's useful for is that it ensures your models remain effective and aligned with the latest data. And what this means is that this can improve your model performance, prevent model drift from changes in user behavior within your product, and help incorporate new domain-specific knowledge from real production usage. A lot of teams do this already. They retrain over their full data to gain these advantages and keep improving model performance. However, continuously retraining on all of your existing data, as well as new incremental data from production, has a variety of challenges, especially as you start to scale this workflow over time. In particular, it presents significant challenges as your data volume grows over time. And so what I have on this chart is three axes. There's like the y-axis to your left has the cost of full retraining. The y-axis on the right has time to train in hours, and the x-axis at the bottom is time in months. And this is sort of like just a simulated chart, but it's a very real example of how costs scale in production. And what I want to show you here is that the cost of a full retrain and the time required to fine-tune increases proportionally, and this creates bottlenecks that can delay the deployment of updated models. And what's really interesting is that these delays not only impact the model's ability to incorporate new knowledge and stay aligned with evolving data distributions and user behavior, but also pose cost constraints, especially in production settings. And to sort of like get around this, it becomes important to explore alternative training strategies. And one such training strategy that we can consider is this idea of incremental fine-tuning, where we, instead of retraining from scratch, where we can take our existing model and continue to train it on only the new incremental data. And that's represented sort of by this line in the red. And the idea is that if we can do this really well and eke out performance gains, right, then our costs scale very slowly. We're able to train pretty consistently and pretty quickly. It's an ideal way for us to keep our models up to date in a very flexible and easy way. And to visually illustrate what this might look like, let's say you start with an existing LoRa that you've already trained. Now, for those who aren't familiar with fine-tuning, a popular method for fine-tuning that's cheap, easy, and quick is this idea of parameter-efficient fine-tuning. And one of the methods to do this is by training a LoRa. And it's a set of weights that you can insert into a base model, and you can train the model to only update these weights. And these weights essentially learn how to perform your specific task. So let's say you have a LoRa that you've trained over your data. We'll call it original LoRa, and another, and your data set represented in green, the original data set. You can either resume training on the same data set for additional epochs, to continue to refine the model's understanding of existing data, or you can actually resume training on new incremental data to add new knowledge to the existing LoRa. And in both cases, the output is an updated LoRa that you can then use out of the box for inference. This has actually been a very popular ask from our customers and even a lot of open dev tier users on our platform. And so we've made it a very simple workflow in Predibase. At Predibase, or within the product, there's essentially two ways to train a LoRa, either through our SDK or through our UI or web app. And when using the Predibase SDK to train your initial LoRa, all you need to do is call the adapters.create method and pass in your data set along with your fine-tuning config. The fine-tuning config lets you specify a base model of your choice, and we support about over 100 base models. Configure important LoRa parameters like target modules and rank, and then also set a variety of learning parameters like epochs, learning rate, early stopping, and many more. And when you run this, essentially Predibase will handle the training and end up training a LoRa over your data set. Now, once your initial LoRa is trained, you may want to resume training from it. And the way to do that is very, very simple. All you need to do is add a new attribute or new attribute or argument called continue from version and point it to your LoRa. So initially we trained my repo, and we had a repository called my repo, and we trained our first version, so /1. So you just have to point it to that. And the next thing you can do is specify a data set. And you have two choices here. You can either specify the same data set again if you want to train on new data, or actually point it to your incremental data if you want to train for longer. And what's really interesting is that actually handling both of these cases requires a very different setup and a lot of special work. And internally, we figured out ways to manage state in a special way so that we can reload the model correctly in both scenarios to maximize performance. If you use the Predibase app for training, I apologize, the screenshot's a bit small. It's even easier to retrain or continue training. You can click on the kebab menu on the right, press continue training adapter, and then you can choose your adapter type, fine-tuning task type, completion style or instruction tuning, adjust learning parameters like epochs, learning rate, just like in the SDK. And finally, you just hit train. And on the top right, you can choose the same data set, or a different data set. So I've actually spent a lot of time talking about incremental training. And this is because, to me, it seems like a logical thing to do to prevent retraining on the same data over and over and over again. And what it should do in theory is improve our training time to a new production model, as well as reduce our costs. But the question we still need to answer is, does incremental training really work? So to understand this better, we can set up our experimentation to have 3 different scenarios to really evaluate how well incremental training works. The first is training using only original examples. So that will be scenario 1, and that will serve as our baseline. The second is mixing original and new examples, or sort of the incremental data, in small proportions. Let's say keeping 90% of the data as your original, and then retraining or continuing to train on 10% of your data. And the third is a more extreme case where you continue training on as much data as you originally trained on, right? So that's essentially like the idea here. And keeping these 3 in mind, we can first take a look at scenario 1 and then talk about scenario 2 and 3. So we actually benchmarked sort of incremental training across a wide variety of tasks, not limited to paraphrasing and phrase correction for editing tasks, structured generation, named entity extraction, information extraction, summarization, classification, and many more. And I just picked, maybe one example that's much easier to illustrate the performance gains, but this trend is true across all of our experiments. So our baseline is scenario 1. And what we see is that in this case, we trained on all of our data, and the performance we got, the x-axis is actually precision. Forgot that it's missing from the chart, was around 0.85%. So it makes sense to look at scenario 2 and 3, where we perform incremental training on subsets of data. The results show that incremental training improves model performance, with the largest gains observed when you continue training on a larger volume of incremental data as seen in scenario 3. And while the gains are proportionally smaller in scenario 2, we can see that incremental training also improves precision here. And we saw this across all of these different task types. But the question, if we're honest with ourselves, is compared to scenario 1, there's still a fairly considerable performance gap. And the gains from incremental training feel smaller than what we'd expect to see with this retraining strategy. And as it turns out through investigation, this is due to a few key challenges. The first is actually a lack of novelty in new data, which can happen in scenarios where the incremental data set doesn't actually contain net new knowledge to add beyond what the model has already seen before. The second is a potential misalignment with the original data set's distribution because of big distribution shifts in user behavior in production compared to the data set that we originally trained our LoRa on. And finally, the third is the risk of catastrophic forgetting, where prior knowledge is lost or forgotten during updates when learning on new data. So how can we really solve for these challenges, right? Like the promise of incremental training is pretty high. And as it turns out, the easiest ones to solve for from a training perspective are misalignment and catastrophic forgetting. And one method we can use to reduce the effects of these issues is called rehearsal learning. The idea behind this method is to periodically show the model examples it has already learned from in the past while training on new data. For example, we can create a rehearsal data set by merging our new incremental data with a small sample, say 10 to 20% of data we've already trained on in the past. During training, what happens beneath the surface is that because we shuffle our data ahead of training, many batches will have a combination of examples from new and past data. And this helps in grounding the model to retain prior knowledge while adapting to new information during incremental training. And compared to just regular incremental training, rehearsal learning actually significantly boosts performance. The largest gains are seen in scenario 3, where incorporating 20% of past data alongside new data achieves a substantial 3x improvement compared to vanilla incremental training. Scenario 2 also sees a 2x improvement in performance compared to vanilla continued training. Now, these results come from about a week or two of exploration that we've done on within our team at Predibase. And our team is actively continuing research in this area since we believe that it's very important for customers who have fine-tuned models in production. We're already observing even larger improvements from some research we've tried that aligns probability distributions of the initial LoRa's and its incrementally trained counterpart, drawing some inspiration from DPO. And we're pretty confident that we'll be able to close this performance gap even further with some more innovative methods. We're also working on streamlining this rehearsal training flow with incremental training by allowing our users to specify rehearsal data percentages through a new rehearsal percentage argument in the adaptive creation method. Behind the scenes, this will figure out what data set your initial LoRa was trained on, sample data from it based on rehearsal percentage specified, merge it with your new incremental data set on the fly before pre-processing and training. And the advantage of something like this is that it will let you run experiments to maximize performance much more easily without having to worry about creating these data sets yourself. However, there is still one lingering question. As you've seen, training on the full data set still outperforms incremental training in terms of quality, even with rehearsal learning. So what can we do to deal with this, right? Like we have a scenario where we can train much more quickly and efficiently and add new performance, but it's not the same as doing full training. And we're actually seeing most of our customers adopt a hybrid training strategy that combines the best of both worlds. The idea is that we want to combine frequent incremental updates with periodic full retraining to balance performance improvement and cost efficiency. Incremental training provides steady performance gains, as we've seen, while full retraining at regular intervals ensures alignment with the full data set, boosts performance further, and helps prevent long-term drift. Now, if your team is constantly retraining models with new incremental data, it's super important to ensure that your processes are set up well, load the models using very specialized states, avoid catastrophic forgetting by adjusting training parameters, and maintaining alignment with the original data set so that you can maximize performance improvements and model stability. And at Predibase, we're focused on making those workflows seamless and intuitive for our customers so that you can unlock the potential of your data. To wrap up, I want to give you an overview of the Predibase platform. Predibase offers the fastest way to fine-tune and serve LLMs with full ownership of your models and your data. You can connect your data set to Predibase from various sites, customize your training process through our model builder with support for hundreds of models, both open source and more proprietary, such as the ones from Upstage, track versioning, iterate, and compare your fine-tuned adapters train many models concurrently to minimize experimentation time, and deploy your fine-tuned models at scale using our open source project, Lorax. Predibase also exclusively supports a variety of custom adapters that we built in-house, like TurboLoRa, that improve model performance on your task while simultaneously improving your throughput by almost 4 times compared to other open source serving frameworks like VLLM and DGI. You can either run Predibase in our cloud or yours, and we're secure and SOC 2 compliant. And with that, I guess I'm done with my demo. If you want to chat about all things LLMs, you can connect with me on LinkedIn by scanning the QR code on the left or going to pbase.ai/Arnav. You can also get started with Predibase today for free with $25 in credits by going to pbase.ai/get started or scanning the QR code on your right. Yeah, thank you. And if you have any questions, I'd be more than happy to take them now. Michael, you might be muted, I think.
Awkward. I said you guys should definitely connect with Arnav if you get the chance. This guy knows everything about LLMs. Hope I'm not overselling it, Arnav. So a question.
No, lots of overselling, but it's okay.
So one question that came in, what was it? Oh yeah. How do you know if the new data is actually new and different from the existing data? Is that something that we consider, something you've considered? How do you know?
Yeah, absolutely. It's a really good question. So there's many strategies for this, right? Like one is if you take so I'm gonna give you 2 strategies. One is you can take your data, use an embedding model to embed it, and then you can find for each new incremental piece of data, you can look at your existing data and see cosine similarity to see how similar it is to some of the existing examples in your data set. That's a very like naive and simple approach. But I think maybe a more comprehensive approach is that you already have a fine-tuned model, right? So what you can do is pass this as input, and it's going to give you an output. And in the world of LLMs, what you get is for each token, you produce something called the log probabilities. And what you can do is you can multiply those to get a confidence score. And if you find that the confidence is already very high, then it's likely not going to add anything new to your model because your model already predicts it really well. And so that's another way of filtering it out. I've also read some research that says things that are low confidence and high confidence, you can pretty much just drop from your data set. And you only want to keep things that have like middle confidence. So it's not too confident, not too underconfident. And that's another way to filter out examples that will meaningfully add, are likely to meaningfully improve your model on continuous training.
Got it. Maybe one more quick question so we can get to our last speaker. It's more about actually support. Someone asked about VLMs, and I saw that Will answered we do support VLMs now. But what about fine-tuning embedding models? That's something that we can do Predibase. So it comes up a lot. I know it's a hot topic.
Yeah, absolutely. It's something that it's on our roadmap, something that we want to invest in. And we're working with a lot of design partners to figure out the right way to structure this process so that it's very easy to do in the product. And I'm not sure who asked this question, but please, if that's something that you're interested in, reach out and we can work with you to show you what we're thinking about. We've run a lot of experiments both on open models like Mistral and fine-tuning embedding on top of those, as well as more specialized embedding models like the ones from Gina AI. And we consistently see that the performance lift is pretty significant post fine-tuning. So on our roadmap, working with design partners and happy to work with whoever's interested in giving that a try.
Awesome. Well, Arnav, thank you as always, showing us some new technology we're building and how to think about it, continuous training and how to evaluate it and the art of the possible. It's pretty cool stuff.